All right, so let's finish up section 4.3. Right, so today we're going to look at solving equations. Okay, we're not going to be doing any graphing by hand. We're mostly going to focus on equations. We'll do one inequality at the very end. Most of what we solve is going to be algebraic. If we run into a problem that we can't do with algebra, we'll look at trying to do it on the calculator. All right, when we solve, or when you have a fraction, okay, what's the one thing you have to be careful about with fractions? You can't do what?
A zero in the denominator.
Right, you can't have a zero in the denominator. Okay, so we'll keep that in mind, and I'll come back to that. All right, so the first problem we're going to do, let's start with a word problem right off the bat. Okay, the word problem is going to be about a person that's traveling at a certain speed for a certain amount of time, and they're going a certain distance. Okay. That's the formula that relates the three things I just said. Okay, so if you don't remember that, that's handy to write down. Okay, so D is distance, R is rate, T is time. Other than that, I don't think you need any other background information to do the word problem. And so we'll just start with that. Okay, one thing you might have to do, though, is rearrange that equation. Like right now, I have D by itself. You might have to rearrange it so R is by itself, or T. Any questions on how to do that? Like move R to the other side, or move T?
Divide by.
You divide by whichever one you want to move, yeah. Okay. All right, so this person is traveling somewhere, and they're going to drive to the train station, and then from there they're going to take a train. It's basically what's happening. So it says Sue drove 30 miles to the train station, and then from there she got on the train. Okay, the total length of her trip, in just one way, starting somewhere and going somewhere, is 120 miles. Now, we don't know how fast the train goes, we don't know how fast the car goes, but what we do know is that on average, the train is 20 miles per hour faster than the car. Okay. Any questions on anything that's written there? Anything that's unclear or not kind of confusing there? Okay. So what I want to do is come up with an equation that tells me how long it takes for her to complete her trip. So all you have to do is you're going to tell me how fast she drives in the car. I'm going to take that number, I can plug it into the formula that I'm about to come up with, and it'll say how long it takes to do the whole trip. Okay, so find an equation for the time it takes to complete the trip, and the variable I want you to use is x, and x will represent the speed of the car, not the train. But if we know that the train is 20 miles per hour faster than the car, and the car is x, we can figure out the speed of the train using an x. Okay, so we'll come back to that. All right, so the time, that's the total time. It's not just the time it takes for her to do it in the car or just the time on the train, it's the time for both. So if you knew how long she was in the car and you knew how long she was on the train for, what would you have to do with both of those to find the total time? Add them. Okay, add them together. So first thing I'm going to write down is just kind of the big idea of what we're doing. The total time is equal to the time, we'll just write T sub car, that means time in the car, plus T sub train, the time on the train. Now we have to figure out each of those times. Okay, what's the formula that relates distance, rate, and time?
D equals RT.
D equals RT. How would you rearrange it so time is by itself?
D over R.
Yeah, take the distance divided by the rate, and and there's your time. Okay, so let's that's going to be our time. Let's start with the time in the car. So we have to find the distance in the car divided by the speed of the car. And that'll give me the time in the car. What was the distance she traveled in the car? 30 miles. What was the rate she traveled in the car?
This is C equals C plus 20. So we don't know the exact rate.
We don't know the rate, but they did tell us how to write it. What's the speed of the car? How did they say to write the speed of the car?
As X.
They said as x, the speed of the car. Okay, so x is the speed of the car. Okay, plus, now we need to find the time it takes to travel on the train. So you're going to take the distance on the train and divide it by the speed of the train. Okay. What's the distance that she traveled on the train?
90 minutes.
90, right? The total trip is 120. She did 30 in the car, so she must have done the rest on the train. So 90. And what about the speed of the train?
X at 20.
Right. It says the average rate of the train is 20 faster than the car. So if the car is x, the train is x plus 20. And there's our formula. So now all you'd have to do is tell me the speed of the car. I could fill it in, calculate it, simplify, and I would get how long the trip is going to take. Any questions on how we came up with that? Okay, we're going to use that in the next couple problems. Okay, we'll figure out some things. Like I might give you something and say, suppose it took her 2 hours to do the trip. How fast was she driving? Okay, we'll do something like that. Okay, another thing we could do is we could combine these together with a common denominator. That might be handy if we want to do some other things with it, but they didn't say to do that here, so I'm not going to. All right, so now I'm going to look at that as an equation, and I'm going to solve for all the things they're asking me to solve for. Okay, but before I solve it, I'm going to write it as a common denominator, just because that'll be helpful when you have to find certain things. Okay, especially the EDM. Okay, so the common denominator, the way you get it, is you just take the two that you have and multiply them together. So x plus 20. What is the fraction on the left missing so that its denominator would be the common denominator?
Yeah, X plus 20.
It's missing the x plus 20. So I'm going to multiply top and bottom by x plus 20. The bottom I already did. The top I would have 30x plus 600. Now let's look at the other one. What is the 90 over x plus 20? What is that denominator missing to have the common denominator? Just an x. So you're going to multiply the top by x and the bottom by x. Well, the bottom, I already have it right there. Xx plus 20. I'm not even going to do it out. In the top, I get 90x. Okay, the only thing we could do is combine like terms. What's 90x and 30x? 120x. If you want to distribute the x out in the bottom and write it as x squared plus 20x, you could. But I'm just going to leave it like that. Okay, so we're going to look at those two things. Any questions? All right, so now let's see. Find the asymptotes. Let's do the EBM first. Because if I find the EBM, that'll lead me to finding the horizontal asymptote. Okay, so EBM, take the highest degree term in the top, divided by the highest degree term in the bottom. What's the highest degree term in the top? It's 120x. And now be careful here because I don't have it written, but what would be the highest degree term in the bottom?
X squared.
If you did it out, it would be x squared. Right? So you have an x in the top, we'll cancel one of the x's in the bottom. And that is your EBM. Okay? 120 divided by x. Now, take that fraction and let x get really big. What happens to this fraction is x approaches infinity.
It's smaller.
It gets smaller and it approaches
0.
0. So my horizontal asymptote is y equals 0. Will it ever reach 0?
No.
No. Even if x is 1,000,000. Right? She's driving 1,000,000 miles an hour. 120 divided by 1,000,000. It still isn't 0. It's very small. Not 0. So we've got the EBM. We've got the horizontal asymptote. Let's do the vertical asymptote. Okay. How do you find your vertical asymptotes? Yep, Casey.
Set the bottom equal to 0.
Set the bottom equal to 0. And this is why I left it factored, because anytime you want vertical asymptote, you always have to factor it. So it would have been a waste of time for me to distribute that out to only have to factor it again. So set the first factor equal to 0. Set the second factor equal to 0. If you set the first one equal to 0, it's already solved. The second one is not. Okay. How do you? What would be the value that would make the second factor? Negative 20. Now, I'm not saying that that makes sense in the word problem. Okay, x is the speed of the car. Okay. So negative 20 miles per hour doesn't even make sense. But all they did was ask me to find the vertical asymptote. Okay, I found it. It just doesn't make sense. Okay. But that is correct. We did everything right. So we got the verticals, the horizontals, the EBM. Complete graph, we'll do that in a second. The zeros. Okay, so that's where your graph crosses the x-axis. That's your x-intercepts. So to find your x-intercept, you plug in 0 for which letter? If you plug in 0 for x, that gives you your y-intercept.
So plugging it for y.
Yeah, you have to do it the other way around. To find your x-intercept, which is, that's what this is. Just another way to say it. To find your x-intercept, plug 0 in for y. And y is right there. It's what's on that side of the fraction. X is on the right, y is on the left. Easiest way to do it would just be to use the second one we wrote. Just set that fraction equal to 0 and solve it. Now, what's the only way that a fraction can equal 0?
If the denominator is 0.
Careful, not the denominator. If the denominator is 0, that's a vertical asymptote. The numerator. Only way this fraction could ever equal 0 is if the top is 0. Okay? So let's set the top equal to 0 and solve it. So 0 equals 120x plus 600. Okay. And if you solve it, you'd subtract 600, divide by 120, and you would get negative 5. Again, does that really make sense in the problem with the speed of the car being negative? Not really. But if you just showed this equation to somebody, like they walked in right now, they would have no idea this is about a car and a train. That's just math. It's just an equation. So now I'm going to find the complete graph. Okay. I think I'm going to type it in as the original. Okay, before we rewrote it. But it doesn't matter which one you use. All right, so we've got 30 divided by x plus 90 divided by, I'm going to need another parenthesis, x plus 20. Okay, now when I set up my window, I already know that I have a vertical asymptote at negative 20, so I at least want to look that far. So I'm going to go negative, maybe negative 30. So let's go negative 30. What's x max? Well, x is the speed of the car. There really is no limit to how fast the car, I mean, mathematically could be going. So I'll set it to 100. Y is the time. Okay? It's not going to take negative time, but for now, let's just look at it the way it is and see what it looks like. There's my vertical asymptote at negative 20 over here. The horizontal asymptote is at 0. And what that represents is y is time. So the faster and faster she drives, the time it takes to complete her trip is getting closer and closer to 0. But would it ever be 0? No, that's impossible. She has to travel 120 miles, even if you traveled 2 million miles an hour. But still, you're not going to get there instantly. It's still going to take a little small amount of time. Okay, so it'll get closer and closer to 0. Okay, so there's a good graph. Technically, the part of the graph that's to the left doesn't really make sense because that's negative speed. The other thing, too, I might want to zoom out a little more just to see if there's anything off the screen we're missing. So let me try negative 30. And let's try negative 40. Just want to see if there's anything we couldn't see, and there was. All right, so by zooming out, I kind of made this other part look more squished. I can't see it as good. But now I can actually see there was a third part to this graph. Okay, that wasn't coming in. All right, so there's your vertical asymptote at negative 20. Okay, and that's it. That's the graph. Okay. Questions on that? Okay. Now for the rest of the problem, we're going to focus on what's in quadrant 1, because that's the stuff that makes sense. Positive speed. So, she has 2 hours to complete the trip. Find the speed she has to travel at to complete the trip in at most 2 hours. Okay, so when I look at this, I think of it as she has at most 2 hours. So it would be okay if she completes the trip in, say, 1 hour, 50 minutes. She doesn't have to do it in exactly 2 hours. All right, so what I need first is I need the formula from the other page. The time to complete my trip equals, now I need to copy it down. Does anyone have the formula that we did, the one where we rewrote it with the common denominator? I know that was the bottom, but what was plus 600? All right. All right. So now it says she has 2 hours to complete the trip. Where would you fill in the 2? T of x. X is the speed of the car. Right? So they're not giving us the speed of the car and saying if she drives 50 miles per hour, how long does it take? They're telling us how long it takes, and we're going to find x. So we'll fill in 2 equals, now copy the rest. And I'm just going to multiply that out because I'm going to have to do it anyway. X squared plus 20x. Okay, first thing I'd want to do is get rid of the fraction. So what can you multiply both sides by so you don't have a fraction anymore? Yeah, the denominator. Okay, whatever's in the denominator, just multiply both sides by that. So you'd have x squared plus 20x. And if you do it on the right, you got to do it on the left. X squared plus 20x. And keep it in parentheses because you want to remember that. So now we have 2x squared plus 40x plus 0 equals 120x plus 600. Now from here, what kind of equation is that? See, look at the highest exponent. That tells you what kind of equation it is.
Quadratic.
It's quadratic. Okay? When you solve a quadratic, you always get it equal to what number?
0.
0. So take everything and let's put it over on the left side. So you're going to have 2x squared. What's 40x minus 120?
Negative 60. Negative 20. No, just kidding.
Negative 80. Yeah, so negative 80x. And you're also going to subtract the 600. Now if you want, you could make this smaller by dividing everything by what? 2. You could do that. Okay, and now at this point, you have two options. You could try to factor it, which I already know doesn't work. Or you could, well, what else could you do besides factoring it? Quadratic formula. So in the quadratic formula, A would be 1, B would be negative 40, C would be negative 300. Now, I already have the answer when you plug it in. Does anyone need me to go through the quadratic formula? How to do it? I mean, the numbers are a little bigger, but it's just like any other problem with quadratic formula.
If we have to use a quadratic formula, will it be written, or do we have to memorize it?
You should know that, yeah. So I can write it down, but you got to... That's a 4. All right, so the two answers you're going to get are x equals, and it's 20 plus or minus 10 square roots of 7. Those are the two answers. So now technically that means she could drive at this speed and complete the trip in 2 hours, or she could drive at another speed. So that doesn't make sense. There can only be one speed she could drive at. So one of these answers isn't going to make sense because it's going to come out a certain way. Anybody know what's going to happen to one of those answers? Yep. It's going to be negative. If you do 20 minus 10 square roots of 7, you would get a negative speed. Okay? So even though mathematically that is an answer to the problem, just using pure math, it doesn't make sense in the word problem because we're talking about speed. So really, the only answer you get here is 20 plus 10 square roots of 7. Okay? Let's just write down what that is. 20 plus 10 square root 7. It's about 46.6 miles per hour. Okay, so solving it algebraically, that's definitely the longer way to do it, but if they ask you to do it algebraically, that's how you have to do it. It's the way you do it. Okay, graphically, that's very quick. So what I'm going to do is, I already have my graph. I'm going to put another line at 2 hours. And I'm going to set my window so that it makes sense. 0 would be the slowest speed. I already know how fast she has to go, so if I go up to 100, that's plenty with extra. Let's put 0 for time, because that's the smallest amount of time you could have. Okay, so there's the time it takes for her to complete the trip as she drives faster and faster. Let's see. There's the line representing 2 hours. So what would I do with those two lines? Yeah, see where they intersect. So calculate, intersect, and we get 46.6. Same thing we got with the quadratic formula. No question on that one. So even if the problem says to solve algebraically, you can at least check your answer in probably under 60 seconds graphically. It's a very quick way to check it.
What did you type in for the like for the equation for that one? U2 equals the.
So the equation, I typed in two separate things. Yep. Whenever you're doing an intersect, you always put one thing in y1, put the other thing in y2, and then see where they cross. And parentheses and everything pretty much have to be exactly like I typed it.
I can't really see. Do you have the double parentheses at the end?
Yes, I do. Yeah. At the end, it's a double parenthesis.
Okay.
Yeah. And that's a parenthesis too. You just can't see it because of the way it copied. Okay, anything else on that? All right, so notice what happened here. We multiplied both sides by, let's go back and look, this. X squared plus 20x. We multiplied both sides by something that had a letter in it. And what happened when you did that is we created an extra answer. Right? We had this minus here and we crossed it out. So whenever you multiply both sides by something with a variable, you may create an equation that has an extra answer that doesn't work. Okay, that only happens if you multiply both sides by a variable. And that answer that didn't work, that's called an extraneous solution. Okay, so an extraneous solution is a solution to the new equation that you created by multiplying both sides by a variable. But if you go back to the original problem, it doesn't work. Okay, so how do you avoid that? Well, you really can't. All you can do is when you're done, check your answer. You have to check it and see if it works. Check your answer. Okay, so we'll practice solving a couple problems. I'll do one that has an extraneous answer. Okay. And I think I'll do one that doesn't. I don't know. There's three different cases. We'll do two of them. I won't have time to do the third one. But I don't think you'll need to see it. Thanks, I'll say, yeah.
For the speed question we just had, would there be something like that on the test?
The speed question?
Or just like
Trying to remember what word problem. If there was, I would at least give you the distance equals rate times time. I would tell you that formula. But I can't remember the word problem off the top of my head. All right, so basically the way you solve a rational equation is to get rid of the fractions. Make it so there's no fractions at all. And the way you do that is you use the LCD, the least common denominator. So like if I had 2 over 3 plus x over 5 equals, I don't know, x over 15. Okay, the way I would solve that would be I would multiply everything by 15 to start. Because if I do that, the 3 is going to cancel, the 5 is going to cancel, and the 15 on the other side would cancel. Everything would cancel out. Okay. So you multiply that by 15, 15, 15. On that side, the whole thing is gone. On this side, now you just have to reduce. 3 goes into 15 5 times. 5 goes into 15 3 times. And I'm left with all 1s as my denominators. That's exactly what we're going to do right now. Okay. I'm more concerned with solving it algebraically. Graphically, it's super easy. You just type that in y1, type that in y2, and look, see where they cross. There's nothing new there. So I'm going to focus on algebraically. All right, so we have a denominator of x minus 1, another denominator of x minus 3, and that. Okay. Look carefully at this one with factors. Does anyone see how that denominator factors?
X minus 3x minus 1.
It factors into the 2 denominators that came before it. Now that, in general, doesn't always have to happen, but it will always happen with the problems I give you, because that makes it a little easier. If that didn't happen, it'd be a little harder to solve. Okay, so now the least common denominator here is the product of all our denominators. We have an x minus 1, so that's part of the LCD. We have an x minus 3, so that's part of it. And then we just have it repeated, so we don't need to use it again. So the LCD is x minus 1 times x minus 3. So you're going to multiply that by x minus 1, x minus 3. Multiply that by x minus 1, x minus 3. And the same thing on the end. Okay, so let's look at the first fraction. What term is going to cancel out?
X minus 1.
Right. X minus 1, x minus 1. Anything that's left, we have to do as a distributive. Okay, what's going to cancel out in the second one?
X minus 3.
X minus 3, x minus 3. Not much to distribute there. And what about in the third one? The whole thing, right? That's x minus 1, x minus 3, x minus 1, x minus 3. Okay, so let's look at what we have left. 2x times x gives me, and then 2x times negative 3. Yep. Now here it's not too tricky, but you're distributing this. If that was a negative, I would be distributing a negative 1. Okay, since it's a positive 1. Nothing changes. Plus x minus 1. And then on the other side, what's the only thing that's left? 2. And now what kind of equation is that? It's a quadratic. So just solve it just like we always do. Okay, if we can factor it, that'll be good. If we can't, we'll use quadratic formula. I think, yeah, this one will factor, I think. So it's 2x squared minus 5x, and then negative 1 minus 2 is how much? Negative 3. Okay, so let's try to factor it. What would my first terms have to be?
2x and x.
It's got to be 2x and x. Because I have a negative constant, I got to have a plus and a minus. Let's just try them in that order. If that doesn't work, we can always switch them. And then we need a 3 and a 1. And where should the 3 go? Let's try it. So we get 2x times negative 1 is negative 2x. 3 times x is a plus 3x. Didn't quite give me what I wanted. So why don't we try switching the numbers and see what happens there. So let's try 2x plus 1. Let's try 3. Try it again. 2x times negative 3 is negative 6x. 1 times x is plus x. What's negative 6x plus 1x? Negative 5. Perfect. Okay. Now set each factor equal to 0. And what value would make the first factor 0? 1/2. What would make the second factor 0? 3.
Negative.
Yeah, negative a half. Thank you. All right. So now the only thing we have left to do is make sure those answers aren't extraneous. When you're dealing with a rational fraction, extraneous means you would divide by 0 if you plug it in. Let's check 3. Could you plug 3 into the original problem? No. Because if you plugged it in right there, you'd have 3 minus 3 and you would divide by 0. So, cross it out. Let's check negative a half. If you plug in negative a half, would you ever divide by 0? No. So negative a half works. It's the only answer. If you got this far and you forgot to cross out the 3, I would take off 1 point. Okay, because it's extraneous, you should cross it out. So in this kind of problem, there's 3 cases. Either one answer works and one doesn't. Both answers work, or both answers don't. So I'll finish up with one more, and I'll either do the case where they both work or they both don't work.
So they're not always going to be in like a word problem? Because the other one you can like kind of tell the speed can't be heard. Or
Yeah, no,
be negative.
you'll have one like that on the test. It's just an equation that there's no word problem with it at all. Yep. All right, so let's try. Oops. The one I just had on the board that I deleted. All right, so just to compare it to the last one we just did, it's pretty much the same setup. Okay. You've got 2 fractions on the left, you've got 1 on the right, and if you factor the one on the right, how does it factor?
X plus 2.
Yeah, it does factor into x plus 2. So what would be the least common denominator here? X plus 2. So multiply everything by what I just said. X plus 2, X plus 2, X plus 2. Okay, but before you do that, cancel out anything that the top and bottom have. It's the same. What would cancel in the first fraction? Second fraction? Plus 2. And third fraction? The whole thing. So if you want to write down the right-hand side right now, we can. It's negative 6. Okay, the left-hand side, the first part is FOIL. X times x gives me x squared. What's x times 2? 2x. Take away 3x. Negative x. And negative 3 times 2? Negative 6. So I get x squared minus x minus 6 plus 3 times x is just 3x. Any question on that? Okay, what kind of equation is that? Quadratic. So we want to get it equal to 0. Okay, so the only thing I have to do is plus 6. Plus 6 plus 6. So that's gone. What about on the left? It's gone over there too. So all I have on the left now is x squared plus 2x equals 0. X squared plus 2x equals 0. So let's see what happens. What can you factor out of x squared and 2x?
X.
You can factor the x. And now, look at what's happening here. We kind of should start to see something that is not good for this problem. Set the first factor equal to 0. And what about when you set the second one equal to 0? Negative 2. Well, let's check 0. Can you plug 0 into the original problem?
No.
No, because if you plug in 0, you divide by 0. Can you plug -2 into the original? No, because if you plug it in there, you would divide by 0. So this problem is no solution. So you saw the case where one answer worked, one answer didn't, and you saw the case where both answers did not work. Okay, so homework tonight, 1 through, okay, just do 1 through 9 odd. Okay, for the first section. 20, we can skip over 22. 24 should be fine. 28 and 31. So we'll go over that first thing tomorrow. Don't forget, I am here for extra help until 3:25 today.